Hey everybody, we are going to be talking today about the different types of transport. The reason that we're doing this is because we are now jumping into how your cells maintain that stable internal environment known as homeostasis. We talked about that as one of the characteristics of life. Up until this point, we have been talking about, the major organic compounds, the carbohydrates, proteins, lipids, and nucleic acids. We've talked about how those molecules come together to form your cells. We've also talked about how your cells can form more complex organs and organ systems to make you. And so now we're just going to talk a little bit about the cellular activities that keep you alive and also keep other living things alive. So we're going to look here, first of all, at a picture of the cell membrane. So in our last unit, you learned that the function of the cell membrane is to regulate what comes in and out of the cell, and also to form kind of a protective barrier around the cell. And so what we have here are just the components of the cell membrane. And you can see here that it is composed of what we call a phospholipid bilayer. And so hopefully that lipid portion is familiar to you. The phospholipids are these smaller structures here. They have what's called a phosphate head. That's that little circle here. And then they've got two fatty acid tails. And you can remember that from our very first unit, our biochemistry unit, where we talked about the lipids and how they have those fatty acids attached to them. So now this is really important because this here is what we call hydrophobic, which means that it will not break apart in water. And so this is one of the things that helps keep the cell membrane together. But it also is porous. It allows some things to move through. Then we have embedded in the membrane all of these proteins. That's what these purple structures are. So that's another really important thing for you to know, is that we have three main types of proteins embedded in the cell membrane. So I'm just going to start over here on the left. We have the receptor proteins. The job of receptor proteins is to send and receive messages. So you can think about them as like antennas, or even, like your cell phone. The next thing that we have is the marker protein. And marker proteins often have these little carbohydrate chains on them. Marker proteins just act like a name tag. They identify the cell. So every cell in your body has marker proteins that identify them as your cells. And this is how your immune system knows to fight off things that don't belong, because bacteria and viruses and things that get into your body that don't belong there don't have the same markers as your cells. And so your immune system will attack them. That's also how allergies happen, but we'll talk about that later on this year. And then the last protein that you're going to find in the cell membrane is called the channel protein. And the channel protein is this one here in the middle that's got the little line, okay? A channel protein works a lot like a tunnel, in that it allows things in through the membrane. And so we have two ways that molecules can go across the membrane. They can either cross this lipid portion, or they can cross through the channel. And we're going to be talking about how those molecules move, okay? So let's pause for just a second and take a look at what your notes should look like. Okay, so I have my Elmo here. I'm going to zoom in. And so if I'm taking notes on this, I have here the function of the cell membrane, which is to regulate what comes in and goes out. And then I have the name, the phospholipid bilayer, and that's the portion that holds the membrane together and also allows things through. And then right here, this is the big deal. So if I was taking notes, I might even put a star around this. The channel proteins, the receptor proteins, and the marker proteins. That the receptor protein's job is to send and receive messages, that the marker proteins identify the cell, and that the channel proteins work like a tunnel so that they transport materials. And if you're furiously trying to copy this down, don't worry, we will definitely post a copy of this to Google Classroom, okay? So let's return to our notes. now that we've talked about the cell membrane and all of the parts of it, let's go ahead and jump right into the different types of cell transport. So actually, all we're going to talk about today is called passive transport. So passive transport has three major characteristics. The first one is that, it's passive. And what that means is it requires no energy from the cell. Passive transport will happen whether or not the cell expends any energy. And we'll talk about some examples of this in just a moment. The other concept of passive transport is that molecules are going to move from an area where they are highly concentrated. Now, concentration just means the amount of a substance in an area to an area where they are less concentrated. So all that means is that in passive transport, the molecules spread out, okay? A really good example of this is when it's time for class to be over and everybody gets up and goes through the door. As you're trying to go through the door, you're pretty densely packed. But then once you get out into the hallway, especially now, you spread out. You give yourself lots of space. And that's the way molecules work in passive transport. The examples that I have here are, somebody spraying like an aerosol fragrance. At first it's very dense in the area where it's sprayed, but then it will start to spread out throughout the room. And then the other example here is if you've ever added food coloring to water, it will start out very dark and very condensed. And then as it spreads throughout the water, it kind of lightens up. Okay, so no energy, high to low concentration. And the last concept is that molecules move with the concentration gradient. So what does that mean? Moving with the concentration gradient just means that these molecules go with the flow, okay? And so the example that I have here is of somebody, tubing. And when you're out on a river, you're not going against the current, you're just letting it take you wherever it will. The best example of this is if you've ever gone to a water park and you get on the lazy river and you just sit back and you let the water take you, right? So the three concepts of passive transport: no energy from the cell, molecules move from high concentration to low concentration, and molecules move with the concentration gradient. So let's pause again and take a look at what our notes would look like at this point. Okay. So here I have the characteristics of passive transport. And you can see I wrote that it requires no energy, that molecules move from high concentration to low concentration, and that molecules move with the gradient. And you can see here, Miss Ayers took these notes and she even drew a little picture. This is the high concentration of the molecules on the left, and this is the low concentration of the molecules on the right. Okay, so the last thing that we are going to discuss is the three types of passive transport. So let's start out with diffusion. Now, if you're taking notes, really all you want to get is just a basic definition of these terms. So in diffusion, I want you to just watch what happens with this animation. We have a high concentration of molecules up here at the top of the cell membrane and a low concentration of molecules down here. So since we're dealing with passive transport, I want you to think, what is going to be the movement of molecules? Okay, now I want you to watch. Did you see? I'm going to back up, and I'm going to go one more time. So the molecules moved across the lipid portion of the membrane, and now they are more equally distributed. So they moved from where they were highly concentrated to where they were less concentrated until they reached equilibrium. So in your notes, you might write diffusion is the movement of molecules across the lipid portion of the membrane from high concentration to low concentration until, and this is another word for you to know, equilibrium is reached, or until they reach equilibrium, whatever you might put there. Okay, so now let's move on to our next kind of transport, a passive transport. So next we have osmosis. So here I have my water molecules. I have a high concentration over here on the left and a low concentration here on the right. And this big black line represents my cell membrane. And so again, diffusion was the movement of molecules from high to low concentration. What do you think is going to happen here? And so again, notice that they moved from the higher concentration to the lower until again, they were equal. So this is just like diffusion. The only difference is that this is the diffusion of water, okay? The movement of water is so important that it's been given its own name. So in your notes, you might write osmosis is the diffusion of water, or if you want to go even further, you would write osmosis is the movement of water from high to low concentration. And that's really the key there. That's the thing that you're going to have to remember throughout this unit is if we're going from high to low or the opposite. We'll talk about that later. All right, this is the last one that we're going to look at, and it's called facilitated diffusion, okay? So we said that diffusion was the movement of molecules across the lipid portion of the membrane. So now I want you to look at how these molecules move. Look, they bounced off the lipid portion. They had to move through these proteins. Do you remember what we called these proteins? Right, we call them the channel proteins. So the channel proteins help these molecules to move across. That's what facilitate means, to help. So facilitated diffusion is, again, movement from high to low concentration using channel proteins. Okay? So those are the three types of passive transport: diffusion, osmosis, and facilitated diffusion. Later on, we're going to look at what can happen to a cell because of the movement of these molecules. And then we will end by looking at the opposite of passive transport, which is active. This is all for today. Let's take a look now at what our notes look like. So we're going to end with the types of passive transport. And so I have here diffusion with a definition: the molecules moving from high concentration to low concentration through the lipid portion of the membrane until equilibrium is reached. Osmosis, again, movement of water until equilibrium is reached. And then facilitated diffusion, which is the movement from high to low using transport or channel proteins. So, and another thing I just want to point out, just a really good technique, is this use of different colors to sort of highlight the key terms. Okay.